Okay, so welcome to my CSINT prep course. This is NT2540. This is Lab 2. So this one's kind of weird because we don't have assessments. I just have a bunch of pre-lab setups for you guys to do. So I've already posted this in the announcements, but we're going to be working on several different parts. So Part 2, Chapter 8, we're going to try to complete all of those labs. Part 4, Chapter 16, all of these labs. Also in Part 4, Chapter 18, all of those labs. And what we're supposed to be turning in are these 2 assessment labs, but they do not exist. So what I'm looking for is an attempt on the prep labs for credit for our actual labs. I went ahead, I already logged in to our simulator. I'm going to go ahead and open up our simulator. And again, I'm starting with just the very front, the very top one. Part 2, Ethernet LANs and switches. Chapter 8, I'm going to start with configuring a host, and I'm just going to work down the list. So I'm going to go ahead and sort it by lab type, by chapter. I want Part 2. I want Chapter 8, configuring a host name. Okay, in this lab we're looking at how to set up IP host names that will be configured based off of name instead of IP address. So, first of all, where's my password? You'll see that characters on the screen don't actually type. You can type anything in. So, first thing, let's go ahead and log in. If all I did when I clicked on the cursor, I just tapped enter a few times to give me this prompt. So I'm going to go ahead and go to our exec mode. And again, type in the appropriate password. Notice that my prompt changed. So now that I'm at a user mode, let's try to see if we can ping, because we're on R1, let's see if we can ping the FA interface and the serial interface of R2. So ping, let's do the fast Ethernet first, 172.18.0.1, and it worked. Let's try to ping the serial interface, 17.0.2. It also worked. So did the pings work? Yes. So I'm going to go down to step 4, enter the global configuration mode. We did that by doing configure terminal. So once we are here, we can actually create a host name. So we do that by typing in IP host R2 serial and then give it a IP address. What we just did with IP host was we statically set a name or domain name to that IP address. We're going to do the same command for the LAN interface. And again, we're going to put the LAN interface 18.0.1. And let's go ahead and back to our exec mode. And let's try to ping them. R2 serial. Oh, helps if I spell serial correctly. R2 hyphen serial. Just like the IP, it should work. Ping R2 LAN. We're just using these domain names to mask their IP addresses. Did it work? Yes, it did. Did it work when we pinged R2 LAN? Yes, it did. So one last thing, let's do a show host to see what hosts we know. Oh, I'm just fat fingering everything today. Show host. That way it will show you our static mapping. That host name is associated with that IP address. Yes, it did. And that is the end of that first lab for configuring host names. Let's go and click on Grade Lab. Got 100. So let's go ahead and move on to the next lab. The next lab should be configuring local usernames. And it is. So we can get started. Okay, so again, we're going to be here configuring local usernames. So connect to R2 console port using the simulator. So go to R2. Let's go ahead, get into our privilege exec mode. Again, no password is being prompted yet, so they're not set up. Let's hop into our global configuration mode, so configure terminal. Configure team. And we are going to set up our VTY connection. So line VTY 0 through 4. And the global configuration shows, so why does the command line change? Because we are configuring a line so we're going to create a username. But what's really funny is we don't do this from this line. We actually do it from the global config mode. So username R2 -user. Password Cisco Press. That's one user. And again, our prompt should be seeing I actually exited out of the line so I could do my username at the config mode. Sometimes it will let you do a global config mode in a sub configuration area because it knows, oh, I'm going to kick you out and put it in that area anyway. So we're going to go ahead and hop over to R1. We're going to go ahead and get into our user mode. So we're not going to our exec mode. Let's go ahead and do telnet. And try to telnet to R2. It does let us in. Notice the prompt changes. So, describe the text that appears. We get into R2. So I want to go ahead and log into it. But you'll notice no password has been set. Okay, so what's funny is that should not work. We're missing a few things. So let's go back to line VTY. And we actually need to tell it login local. Because if you do not, it did not like, it lagged out pretty bad. So yeah, just one login local will suffice. Login local will actually tell you, the router or the device where to grab the login credentials. Meaning, without this, we can't log into it. So I'm going to hop back over to R1. I'm going to tell that back to R2. And now it should prompt me for a username and password, because it knows with that login local command on R2 that it's going to be verifying it against a local username and password. So that's actually the end of this lab, so let's go ahead and grade the lab. See, I did not see anywhere in the instruction where it said to type that command, but it's not showing as an extra command. So here is a good example of lab instructions being incorrect. So let's go ahead and move on to the next lab. This should be configuring IP settings. It is. So let's go ahead and get on to our switch. Let's get to our exec mode. Let's do a show interface VLAN 1 so we can see all the details. It's currently administratively down. So, is there an IP configured? There's a MAC address, but no IP address. So let's go ahead and enter our global config mode. Config T. So from there, let's go ahead and navigate to our interface for VLAN 1. And the command to add an address is IP address. The address space the subnet mask in dotted decimal form. Also, issue a no shutdown command that basically says don't shut down, or turn on essentially. You should notice a change in the state to up. Let's go ahead, I'm going to hit Control Z to go all the way back to the end. I'm going to do another show in VLAN 1. And you'll notice now I have my IP address. And it is set. So yes, I see it. So now it has a working IP address. Let's try to ping PC1. Did it work? Yes, it did. And that's the end of that lab. Let's go and click on grade, 100%. Let's move on to the next lab. This should be interface settings 1. And it is. Okay, so we're connecting to switch 1. We're going to go ahead and tap enter a few times. Let's go ahead and get to our global configuration mode. We do that by enable, and then config T. So now we're at a global configuration mode. Let's navigate to our FA0/1 interface. So interface F0/1. So notice how the font changes. So let's go ahead and configure the switch port for 100 megabit full duplex. Now this is weird because normally this is already preset for you. So it may or may not work on an actual switch. I'm going to Control Z to get kicked back out. So let's see if these actually take effect. Show int FA0/1 and full duplex 100 megabit. So yes, it did. So let's go ahead and configure the switch port. connected between PC2 and R1 to use 100, or sorry, instead of 100, we're going to set it to use 10 megabit full duplex. So, the switch port connected to PC2. That's going to be FA02. Let's get back to our global config mode and FA0/2. Speed should be set to 10. Oh. Speed set to 10. Duplex set to full. Duplex. So there is some lag with the simulator. Duplex. Alright, so, and R1 will be set to 10, so interface 0/3, speed to 10, duplex to full. So I've finished that part. So we could have done that individually, or we could have actually done a range. So how to do a range is we just type int range FA 0/2 space -3. And you'll notice our subconfig will go to a range. Speed 10, duplex set to full. So we could have done it either which way. It does not matter. So let's go ahead and let's verify that both of the interfaces are using the correct duplex and speed. So let's go all the way back to Cli Exec Mode. Let's do a show run. And for FA0 and so 0/2 and 0/3, our speed is set to 10 and our duplex is set to full. Yes, it is. We could have also done a show interface status, but we'd have to do it for both of them. Let's grade our lab. Since I didn't do it as a range at first, I did it individually. I got some extra commands, but got 100%, so we're good with that. Let's go to the next lab. Yes. This should be interface settings 2. Okay, so interface setting 2. Okay, so I had to log back in because it didn't like me being idle for so long. So let's go ahead and connect to switch 1, which I've already done. I'm going to log into it. So let's go press. I'm going to go to our global configuration mode. So configure key. That will take us to our global configuration mode. We actually want to configure interfaces between 11 and 20. So int range FA 0/11 space -20. Oh, did not like the word range. So we're going to be adding a description to these. We're going to be calling them unused ports. And if they're unused, I like to shut them down. If they're not used, turn them down, turn them off. Best security practice that we can do. Let's go ahead and go back to our exec mode. Let's do a show run to make sure that they are accommodating. Okay, so starting with 11, description is unused ports and they're shut down all the way to 20. 19, 20. Notice 21. Following that, they are not. show run. You could also do interface description, that also works. So disable the same switch ports. Oh, happens to be that I already did that. You get used to doing this, and so the second I see unused ports, I turn them off automatically. So I actually already did step 7, 8, 9, and 10. So let's go ahead and let's look at show interface description. So we could actually look at the specific descriptions of them. Or we could also do show in status. And that will also give us their status plus their names. Also give us things like their duplex speed, the VLAN, media type, and so forth. So that's actually for this lab. Let's go ahead and grade the lab 100%. Let's move on to the next one, which should be interface settings 3. Alright, click on switch 1. Let's go and get logged in. Let's go to our exec mode. And let's go ahead and do a show run. And we want to view the configuration for FA03. It's half duplex and a speed of 10. So, duplex, speed of 10. We could also just do the show int FA0/3, but you'll notice it gives us more detail, but it still gives us the same info. It is still a speed of 10 and half duplex. Let's go ahead and do some editing. Okay, so if your console freezes, just gotta be patient, because it is not always the very responsive. So let's go to our configure terminal, so we're in our global config. Let's navigate to our FA03 interface. Let's do no speed, meaning we will not hard code a speed, nor will we hard code a duplex. So let's go ahead and go back to our exec mode, and let's do a show run. You'll notice FA03 no longer has a speed or duplex setting. Missing speed and duplex. So let's go ahead and let's do a show int FA0/3. And again, you're going to notice full duplex on 100 megabits. That's because it auto-negotiated with full duplex and 100 megabit. And that's actually it for this lab. Let's go ahead and click on grade lab. Should be 100. Alright. Let's go to the next lab. Okay, let's go connect to switch 1. Get logged into it. Let's go ahead and go to our exec mode. Let's do a show int status. Oh, there we can see all of our connections. We have one for VLAN, and we have one for FA01. You'll notice FA011 has not connected. We're looking for connected and not connected. So connect to R1 from the simulator. So let's get logged in. Let's get to our exec mode. Let's do a show int fa0/0. You notice it's administratively down. So that could be why the connection between R1 and switch 1 doesn't work. So let's go ahead and hop into our global config on our router. Configure terminal. Let's navigate to that FA0/0 interface. Let's turn it on with no shutdown. Let's go and go all the way back to our exec mode. Let's do another show interface. Oh, notice now it's on. So let's go to our switch. Let's reissue the show int status. And you'll notice now FA011 is on. That's it for that lab. One of the things that you have to realize is these cables have two ends. If one end is turned off, then the other one is not going to work. Let's go ahead and navigate to the next lab, which should be interface status 2. There it is. Alright, so let's go ahead and connect to switch 1, which we already are. Let's go ahead and get logged into it. Cisco press. Let's go ahead and get to our exec mode. Let's go ahead and issue a show int status. Notice again FA01 and FA011. So I'm not connected. So let's go ahead and issue a show int FA011. This time it is down and the protocol is down. It's down. So that's one of the important ones, is it is not connected, so meaning it is down. So let's go ahead, let's hop into our global config mode. So config t int fa0/11. Okay, I take that back, I'm getting ahead of myself. FA01. Let's go ahead and shut this interface down. So we turned off FA01. We're going back to our exec mode. Let's do a show and status. So you'll notice by turning off the interface on this device, I don't get a not connected, I get a disabled. Meaning, for FA011, it's probably not administratively down on our end, it may be admin down on the other end. Disabled. Let's go back. Show int fa0/1. Notice it says administratively down. Meaning, if it's administratively down, it's turned off on our side. So we got to disable on this side because we turn it off on this side. If we go to R1, we should see that FA011 is disabled. So you know what? Let's see if that holds true. On a router, I want to do an brief. Oh, notice right there. It is administratively down, so we were right. So that's a little bit extra, not what we needed to do. Let's go ahead and grade the lab. 100%. Because I looked at FA011 also, I got an extra command, which that's okay. Let's go ahead and move on to our status 3. Yes, I'm sure. Alright, let's go ahead and hop on switch 2. Logged in. Let's go ahead and do a show int status. So here we're looking at the speed of FA1. It's 100. And it's also showing not connected. So let's go ahead and let's do a show run. Here we have the FA01 manually set to 100. So here we're looking at speed 100. So let's go ahead and so we have to figure out why this is functioning, why is this not working. So it turns out that router 2's interface that our switch is connected to is manually set to 100 or 10. And so we have a speed mismatch. So what we have to do is we need to either configure the switch interface FA01 that connects to R1 to 10, or we need to set the router's interface set to 100. So what our lab has chosen to do has been to set the switch interface down to 10 megabits. So let's go ahead and hop into our global config. Let's navigate to that appropriate interface, FA0/1. Let's change the speed to 10. Give it a second. Let's go back to our privilege mode, and let's do a show int status. And we should show that it is now connected at 10 megabits, but it is connected. That's because both ends of the cable need to be the same. Let's go and click on Grade Lab, 100%, and let's move on to our next lab. Interface status. Okay, so this is interface status 4. Let's go ahead and get connected to switch 2. Let's go ahead and get logged into it. Let's get into our exec mode. Alright, it wants us to do a show interface status. And again, notice we have F2 connected at auto full duplex and auto 100, but FA01 is not connected, even though we see in the diagram it needs to be. So what speed is listed? It is listed at 100. Alright, let's connect to R2 from Cisco Press. Get logged in to our router 2. Let's go ahead and get to our show interface FA0/0. You'll see that the line is up, but the protocol is down.
line up, protocol down. What does that mean? Sometimes that means there's a mismatch in layer 1 or layer 2. Normally it means layer 1 though. And you'll notice that the speed is set to 10 megabits. So let's go ahead, hop over to switch. Oh, sorry, I take that back. Let's go back to R2. Let's actually configure R2 so that the speed is set to 100. So let's go to our config terminal. Let's get to interface FA0/0, speed 100. And you'll notice it should turn up. That is because both sides are now at 100. So let's double check. Let's hop over to switch 2. Let's reissue our show int status. You'll notice there it is set duplex full, but speed is manually set to 100. And now she is connected. And we are done with that lab. Let's go ahead and click on Grade Lab, 100%. Alright, let's move to the next one. It should be setting a switch password. Alright, let's go ahead and connect to our switch. Let's go ahead and get into our exec mode. Let's go ahead and get into our global configuration mode. Let's go ahead and configure our virtual connection, so line VTY 0 through 15. And our prompt looks like that, because we are in a line subconfiguration. Let's go ahead and put password Cisco Press. Let's go ahead and put login. That way it knows when to prompt us. Now let's do an enable secret. It's a secret. Even though we cannot do an enable command on the config line, notice it kicked us out and put us in config mode. This command was actually issued at the config prompt. So let's go ahead and let's connect to R1. Let's go to our exec mode, and let's do a telnet to our switch. And it will ask us for a password. That should be our Cisco Press. When we go to enable, this is our secret password. So it's a -secret, and now we're in. So after looking at our switch, we did our enable, so we already did that. I got ahead of myself up here. I kept working. I apologize. Let's go ahead and grade our lab. Now, all the way through is good. Let's hop to our next lab. And this should be Cli Configuration Process One. Alright, let's go ahead and hop over to switch 1. Let's get into our exec mode. So enable. So, are we prompted for a password? No. Because currently we don't have a password yet. Let's get to our global config mode. If we do a question mark, find the command that changes the host name, list that command, that happens to be Hostname. Also is right there. Let's go ahead and change the host name to Fred. Notice the prompt changed from switch to Fred, because that's the name. It immediately takes effect because this is a running config. Let's go ahead and exit out. Let's go and do a show run. And you should be able to see hostname Fred. There it is. So, to view the switch that will be used the next time the switch is reloaded, can we see... Sorry, I did show run. Let's do a show start. You'll notice hostname is not there because we haven't saved it yet. So hostname is not there. Oh, that was hostname Fred. I messed up. That is no. So let's go ahead and save it. How do we save it? We save it by doing copy, run, start. That will copy the running configuration to the startup config. We can name it if we wish, or hit enter. And now, if we do a show start, you'll see that hostname Fred is there, because we copied our running config to our startup config. So yes, it now can be seen. That's because, again, we copied our running configuration to our startup configuration. That way, the next time it's reloaded, we should be able to see our current configuration. Go ahead and click on Grade Lab. 100%. Let's move on to the next one, which should be Switch CLI Configuration Process number 2. Okay, let's go and connect to the switch. Let's go and get logged in, get to our enable mode. Did we have to do a password? No, we did not. That's because of the default configuration. Let's get into our global config mode, so configure terminal. Our prompt changes to a config. So let's go ahead and change to our interface FA0/1. Notice our prompt then changes again to a config-if. Let's move back to our global config by typing exit. Let's go ahead and set a enable secret password. So enable secret. Cisco press. Let's go ahead and go all the way out. Disable, so that way we're going all the way back out to our user prompt. We're going to go enable. Notice we get prompted for a password now. That's because right here with this enable secret password, that means at the enable point, to going from user mode to exec mode, we put a password Cisco press. Alright, that was the end of that lab. Oh, so apparently I forgot to do a description for our FA01. I totally missed step 6. So let's go ahead and go back to that interface FA0/1. And let's go ahead and paste that description in there. So description, this is a connection. Now we should be done. Grade, There we go. Those are the commands I had to set. So let's go ahead and move on to the next lab. This lab should be Switch Cli Exec Mode. Okay, let's go and get connected to switch 1. Let's go ahead and do a question mark at our user mode. So write down the most interesting 2 or 3 commands. The big one is enable, show, telnet. Let's do an enable. Are we prompted for a password? No, we're not. We have not set a password. Let's go ahead and do a question mark. You'll notice different commands. In a Cisco router, your commands are based off of the prompt that you're in. Yes, there are more. So use the help in both user and exec mode. You'll notice that we see configure and reload. In enable mode, we don't see when we're in user mode. There are a lot of commands. For example, reload is just issued at the exec mode. Show is in both. SSH is in both, so is telnet. Resume is in both. But you'll notice setup's not. So, I mean, a big part of this is going through so you can figure out which commands don't belong in which areas. Because, again, at each mode, we get different prompts. Just like if we go to our configure terminal and we do a question mark, we get different commands. Go and click on Grade Lab. Alright, apparently it actually wanted me to type disable. Go back to our user mode. Question mark again. Now Grade Lab. 100%. We're good to go. Let's move on to our next lab, which should be switch forwarding. Let's go and connect to switch 1. Let's go ahead and ping 192.168.10, 100. So it helps if I pay attention. Let's log in first. So now that I'm logged in, let's go ahead and ping the first address, 192.168.100.2. Okay, let's go ahead and ping 100.3 and 100.4. So all of those are pingable. Oh, I take that back. Sorry. We're supposed to do this from S1. Let's try this again. Ping 192.168.100.2.3.4. So we can. Let's go ahead and connect back to our switch 1. Let's get into our exec mode. So before viewing the MAC address table, write the ports on switch 1 which we expect to see the hosts connected. Well, we should see all of these guys on GI 01, and we should see PC 1 off of GI 02. That's our local port. We should get both of those MAC addresses and both those PCs, because both of those are being routed through that port there, so that's right. So let's verify this by doing a show MAC address table dynamic. And that's what we got. So, can you see how we can use MAC address tables to track down the location of particular hosts? Yes, because we know that these two hosts are off of Gigabit 01, meaning there's probably another device or another switch off of that port. That's it for this slab. Let's go ahead and grade. Oh, I take that back. I got a little ahead of myself. I did the show MAC address on switch 1. Let's do it from switch 4. Enable. Show MAC address table dynamic. And we should get a similar set, except PC2 will be coming off of FA012, and everything else should be coming off of Gigabit 01, because on this local device, that's the port that goes everywhere else. So that's correct. Grade lab, everything is good. Let's move on to the next one. Here we're dealing with switch IP addresses. Let's go and connect to switch 1. Let's go ahead and get to our global configuration mode. So configure terminal. Let's go ahead and go to our interface VLAN 1. We're going to be programming a IP for our switch. The command should be IP address, and we are setting an address of 172.16.160.3 space. Subnet mask is 255.255.224.0. Oh, I spelled address wrong. Let's do a no shut to make sure it's turned on. And let's go and exit out. Let's configure a default gateway. We configure the default gateways through our global config, and that is IP default gateway and the IP address 172.16.160.1. It's, notice, no subnet mask here. So it's assuming that this is part of our local LAN, and this is the address for our router's interface. Let's go ahead and hop over to PC2. Let's go ahead and try pinging 172.16.192.12. And it works. And that's the end of this slab. Let's go ahead and grade lab. Got everything done. Let's move on to the next one. This one should be switch IP connectivity. Alright, let's go ahead and connect to switch 1. Let's get logged in. Let's go all the way to our global configuration mode. So config T. Let's go ahead and go to our VLAN 1 interface. So int VLAN 1. Let's set the IP address of 192.168.100.2 with a 255.255.255.0 subnet mask. Let's do a no shutdown. So let's go ahead and exit out. Let's do an IP default gateway of 192.168.100.1. That is going to be the router's interface for our LAN. Now let's go ahead and hit type end. From switch 1, go to enable mode prompt, and let's ping our gateway address. So ping 192.168.100.1. It should work. Did it work? Yes, it did. So let's go ahead and grade our lab 100%. Now let's move on to the next lab. Interfaces and forwarding. Okay, so that is not our next lab. So let's go ahead and go home. We're looking for switch interfacing and forwarding. So this is actually a configuration scenario. So we have a lot more steps now at 31. So let's go ahead and get started. Connect to our switch. Let's try to do a show interface. So we already know to log in it should be Cisco Press. Let's do a show int status. Oh, we see that the first three are FA0, FA0, 1, 2, and 3 are all disabled, and Gigabit 0 are disabled. They're disabled. Or administratively down. So try to predict any interface subcommands that we're going to be configured, and that will be shut down because they are turned off. The disabled interface does tell us that the command shutdown was issued. So let's experiment with switch 1, FA01 and 02 so we can get them turned on. So let's move to our global configuration. So config T. So let's go ahead and navigate to those interfaces. So int range FA0/1 through 2. So I did FA0/1 space hyphen space 2. Sometimes you don't have to, sometimes you do. I've gotten into the habit of it. Let's do a no shut on this. And let's go all the way out. Let's do a show interface status. Show int stat. So you'll notice they are now connected and auto full and auto 100. So what do you suppose the A in it means auto? So use the show interface FA1 command and FA0/1. So does the speed and duplex information apply anything whether auto negotiation is used? So full duplex 100 megabits. I don't see anything for auto negotiate, so no. It doesn't state how it's learned, but they're there. So let's move back to configuration, then move to the interface FA02. Let's set the duplex to full. So config t int fa0/2 duplex full. So it's no longer auto. The one's missing a, or fa0/2. So let's go ahead and exit all the way back out. Let's do another show int status. And you'll notice it just says full now, not a-full. So let's go ahead and experiment with fa03 now. So let's do a show interface status, which we just did. You'll notice fa03 is both set to auto, but it's still disabled. So right now it is auto. And it's still disabled. So let's go ahead and move to that interface. Let's do a no shutdown to see what happens. Configure terminal, int fa0/3, no shutdown. Let's do an end so we can go back to do a show int status. And you'll notice that fa03 is still not connecting. That means we got a little bit more troubleshooting. So let's go ahead and connect to R1. Because if it's turned on the switch side, is it turned on the router side? So show int fa0/0. Notice it's administratively down. So let's go ahead and move to our configuration mode. Let's manually set fa00 to full duplex. We're not going to touch the speed, and let's administratively enable that interface. So int fa0/0. Let's set duplex to full. Oh, sorry. Get to our global configuration mode. Interface fa0/0. Duplex full. And let's do a no shut to make sure the interface is turned on. And we just noticed it went up. Let's go ahead and exit all the way out, and let's do a show interface status. You'll notice that on a router we can't do that. So let's navigate back to our switch, and now let's do a show int status. A show int status does not work on a router, and you will see that fa03 is now connected auto full. But I thought we changed this to full duplex. So why is it auto full? It's auto full because we set manual full on the router, but on the switch on the other end of the cable, it is still auto. So duplex and speed. So switch forwarding, one of the last things we need to work on. So let's go ahead and connect to PC 1. Let's first start off by pinging 192.168.4.11. It did not work. What about pinging 4.2? That worked. And what about router 1's interface? 4.62. That worked. So So let's go back and let's ping 192.168.4.11 again. It did still not work. So which ones worked? PC2 and R1. Because we have not actually turned on our gigabit interface to allow S1 to be able to communicate. So display the PC1 ARP cache. So we can actually do ARP-A, and there is our ARP cache. Now that we know each of the device MAC addresses, we can now better interpret the switch 1's MAC address table. So display only the dynamic entries in the switch MAC address. So let's hop over to our switch. Let's do a show MAC address table dynamic. And that will allow us to see what was learned dynamically. So predict the path taken when a ping packet from PC1 goes to PC2. Well, PC1 will go to switch 1, and then from the switch 1 will go to PC2, and so forth. So predict the path taken from R1 to PC1. It's going to be the same thing. It's going to go to the MAC address of FA03 and then to the MAC address of PC1. So R1 to switch 1, then switch 1 to PC1. I didn't do the MAC address table, but I mean that's where they're going. Is you would just fill in switch 1 and PC2 with the appropriate MAC addresses and you should be good to go. Let's grade lab. So it did not like the fact that I did a range instead of individual. So for completeness sake, let's go back. Configure terminal, interface FA0/1, no shut. And underneath switch 1, let's do it one more time, no shut. Let's assume we're going to be going to interface FA0/2, doing the same thing, no shut. Because even though we did it as a range, it wanted it done individually. So I'm sorry for that. That's the end of that lab. Let's move on to the last lab in our section, titled Port Security. And I don't think I can hit next. Oh, I could. Okay, so we are doing port security. So let's go ahead and get down to the first set of steps. Let's discover and test connectivity of all devices. Let's connect to PC1. And we already are. Let's go ahead and look at its IP address. So IP config all. And you'll notice we have an address, we have a subnet, we have everything that we need. So let's move to the R1. Let's do a show interface command. They're starting to assume that you know how to get into the appropriate modes. So show interface FA0/0. I take the back, let's just do show interface. and you're going to see all interfaces. And so what you should be looking at is something similar to this. So instead of doing show interface, let's do a show IP int brief. That way we get a little bit better understanding. So move each PC in succession and ping each of the other PCs. So let's do PC1, ping 172.16.1.129. It timed out. Ping 172.16.1.130. It timed out. Ping 172.1.2. It timed out. Let's hop over to another PC. Let's ping 172.16.1.30. It worked. So switch, or S1 can communicate with S2, but can it communicate with PC2? 172.16.1.2? Apparently not. Can it communicate with 172.16.1.1? It cannot. So we can see that there are some issues with our communication. So record the results. S1 pings S2. Pings from the other ones happen to work. So the test should show that PC 1 and 2 cannot ping successfully. So let's move to PC 1 and test that TCP stack is operational by pinging the loopback. So ping 127.0.0.1. It works. So because the TCP stack is operational, we should the next test operation of the PC NIC. So to accomplish this, ping the address assigned to it. So let's ping 172.16.1.1. It did not. There should be a response, but currently there is not. So that's an error in this lab, because this right here is not correct. I cannot ping myself. So ipconfig -all, yeah, ping 172.16.1.1. Okay, it worked the second time around. Oh, I must have been fat fingering something, because it works the second time around. So if yours does not work, try it again. So now moving on to part 2, let's investigate potential problems with the switch 3 interface. So let's go ahead and get onto our switch. Let's get into the appropriate place for us to do a show interface command. So let's get into our exec mode. So let's do a show int fa0/11. Notice the line protocol is down and it's in error disabled. Not administratively down, but error disabled. Let's also do a show int stat. Again, error disabled, not disabled. That's probably because there's some type of port security. So what can cause error disabled? Port security does. Other things do, but normally security violations. So to determine if port security is enabled, let's go ahead and do a show port security interface FA0/11. And it will say port security is enabled. It's in a secure shutdown mode. So if enabled, what action has taken place? It's in a secured shutdown mode. Because of port security being enabled, the interface may fall into an error disabled condition, which we know. What is the current status of the port? It's in a secure shutdown. So let's determine the cause of the issue. Find the source MAC address of the frame that caused it. So let's go ahead and do a show we are actually already here. So let's look at the MAC address. Okay, that was weird. Let me change the MAC address. That is the MAC address of the last source address. What's the MAC address? And that happens to be the MAC address of PC1. That's correct. What interface uses this? FA011. Oh, sorry, it actually asked the total MAC addresses learned, which was 1, total MAC addresses, and total configuration, or configured MAC addresses. That was all 1. Now that we needed to determine that the permit address is, this can be done by examining the run config to see what address is allowed. Because it had a maximum address of 1, and a total MAC address of 1, and a configured MAC address of 1, if it's not configured to use that MAC address, it won't work. So let's do a show run. And let's get down to FA011. Oh, there it is. It is using MAC address 00C3. So that's the permitted one. And that's not what we want. Because the last MAC address it learned was this guy right here. So we actually have to configure it to use the correct address. So examine the running configuration, record the text box below the configuration that as specifically allowed. We do that by switch port, port security, MAC address, and that sets the MAC address. So to correct this, we need to remove the previously allowed address. This will require 2 commands. What 2 commands? No switch port security MAC address 00. And then we want to redo it with the correct address. So let's go ahead and apply these 2 lines. So config T interface FA0/11 Okay, the command prompt does not like that whatsoever. Let's go ahead and make sure that they both applied. Let's do that with the show run. Okay, it did not like that, so let's go ahead and let's do it again, one command at a time. Configure terminal, interface FA0/11. You can also type these out. Alright, so we applied the 2 lines and re-examined the state. It should still be in a failure mode. So let's do a show port security interface FA11. You'll notice the violation mode is still shut down and its status is still secure shutdown. It's still turned off. So we actually have to turn it off and turn it back on so that it will clear that error configuration. So interface FA0/11, shutdown, no shutdown. Let's verify that worked. Show port security FA0/11. I always forget the interface, and you'll notice now the mode is secured and up. So is it operational? Yes, it is. Now can we ping from PC1? Let's try pinging PC2. 172.16.1.2. It's still not functioning. What about, can we ping S1? 172.16.1.129. Oh, we can now ping from PC1 to the rest of them. So, there probably means there's another issue on switch 4. So yes, but can't ping PC2. Did everything there to be operational? No. Let's investigate PC2. So let's go ahead and use the topology from table 1. Let's see if PC2 has the ability to. So PC2, let's try pinging everything again. So ping 172.16.1.1. Oh, it failed. Let's try pinging S1, 172.16.1.129. It failed. So let's try pinging our loopback, 127.0.0.1. Okay, that worked. What about, can we ping our own IP address, 16.1.2? And that also worked. So, no, that didn't work. Step 22, we actually did ping ourselves, and that worked. So because of this, we should now test the operations. We did that. It worked. So let's investigate switch 4. Let's go and get logged in. Cisco Press. So let's do a show int FA0/12. Okay, that's the interface we're on. It's showing up and up. So it's up and up. So let's go and do a show int status. Show int stat. It's showing FA12 connected, VLAN 10, full auto. So, do you appear to be any issues with the switch? No, there it is not. So from the previous troubleshooting experiences with switch 3, is there anything else we should check? What about the mode? Sure, mode and speed. We should also look at port security. So show port security int fa0/12. It is secure and up, but it's also showing as restricted. So it is set to restrict. It is also alright, I'm getting a different output than this is. I am showing secure up, restrict, that's correct. I'm getting MAC address 1, total 1, configured 1. Security violation is not showing greater than 1. So what does this violation mean of restrict? That means it won't send or receive. So the frames with the source MAC address that are not listed as allowed are dropped. So to verify the security violations are preventing this, the next 3 steps suggest that we remove port security. So let's go ahead and display the configuration interface for that interface. Show run. We are looking at those steps. So let's go ahead and remove them. Let's get to our global configuration mode, get to our interface. So we want no port security. We want no violation, and we want no MAC address filter. So, yeah. So let's go ahead and document our commands. Now let's exit back to enable mode and let's repeat the pings from PC2. We can ping S1 now. We can ping PC1 now. Yes, it fixes our issue. So let's do corrective issues now. What's the MAC address of PC2? ipconfig -all. That is our MAC address. So let's go back to switch 4. Let's go ahead and re-enable port security. But this time, let's put the appropriate MAC address there. The switch port, port security, MAC address. Make sure to put the MAC address of PC2. And let's move back to PC2 and let's try this again. Ping 172.16.1.1. It timed out. Oh, that's because I did the wrong address. 172.16.1.1. Yes, it does. Let's try pinging S1. So ping 172.16.1.129. Okay, so it does work. Let's create our lab, and all steps should be there. And we are now done with Part 2 Ethernet LANs and Switches, Chapter 8 Port Security. Thank you.